Okay. Thank you very much for your time. It is a great pleasure to have you. So we have a journal, bi-monthly journal for the membership of our society.
Yeah.
We have 8,500 members, and they are eager to learn what is the top science of aging. So you are, of course, one of them, and so I like to interview you.
Sure.
So I would like to start. A lot of people may attend your lecture, but a lot of people also may not attend. So would you please explain your talk, your future talk?
Yeah.
First.
So, and you can edit this however you wish.
Yes. Also, I like you to take a look of
sure.
the English,
Yes.
then I translate into Japanese.
Perfect. And anything I say, I agree with. I don't change my mind. Okay. So, so I'm a medical doctor.
Yes.
I'm concerned because diseases are changing. Some diseases are becoming less common. Some diseases are becoming more common.
Right.
I'm interested in the diseases that change, especially the diseases that are increasing, like obesity,
Definitely.
asthma, allergies, certain cancers.
Myopia.
I don't know that much about myopia. What is your specialty, by the way?
Eye, ophthalmology.
Eyes.
That's the reason that I'm
Yeah.
interested in myopia.
Yeah, I don't know. It's interesting. Almost right. So, and so the question, and by the way, this is very important. I wrote a book called Missing Microbes.
Oh, I see.
And this book, Missing Microbes, is in Japanese.
Oh, okay. That's Dr. Ito asked you to sign?
Yes,
I should have done it.
It's now translated into 20 languages.
Oh, wonderful.
And it's got a few prizes.
Congratulations.
So I'm very proud. It's
So
my
I like
baby.
to make an advertisement, maybe in the column,
Yes.
introducing his book.
Yeah.
So would you obtain that Japanese version?
Yeah.
The picture. Of
Yeah.
the
In my slide, I show a picture of the book. You'll see it, but you can find it. It's very easy to find.
Okay.
So in the book, which was published about 4 years ago here in Japan,
Right.
but I actually wrote it 7 years ago.
I see.
And I really had the ideas about 15 years ago.
Right.
But the ideas remain true. And the point is that if you have 10 diseases that are going up at the same time,
Right.
are there 10 different causes, or is there one thing underneath everything? And I think there's one thing underneath everything.
Right.
And that is a change in the microbiome.
I
The
see.
microbiome are all the microbes that live in the human body
Right.
that we have co-evolved with, that have been with us since forever.
Right.
And now they are changing as a result of antibiotics, cesarean section, clean water, bathing, antibacterials, formula that children get, many things. And so that's the hypothesis, is that our microbes are disappearing. Our ancestral microbes are disappearing. And that's where the diseases are coming from. And especially important are the microbes that we get from our mother early in life. And so in my work and in my talk, we examine this hypothesis.
It is very, very interesting hypothesis, and maybe true. So, how do you think when is the turning point of the human being? Because obesity and asthma, a lot of diseases you have just mentioned. When? 1950, 1960?
Yeah,
When?
probably 1950.
1950.
Yes.
So, if we look,
But
these,
let me just say, there's no one turning point. It's kind of a continuous.
Yeah.
But I will show you 3 slides that all point to 1950.
okay.
Which is when antibiotics
So if
came
the
into use.
if the disease which is increasing dramatically after 1950 may be related to microbiome.
Yes, that's the whole point of my book. It actually began before 1950. It began before that, but the biggest shift, maybe it was going like this, and then it goes like that.
We have found interesting myopia You said it's not your field, but increasing after the 1950, and we have just had a presentation. The microbiome is related to the myopia development. So not only the systemic disease, but also the eye disease.
Yes, everything. Because the microbes are our partner. We have partnered with the microbes for the last 1 billion years. Every animal, every plant has a microbiota.
So there's a lot of discussions. Okay, so there's a connection, microbiome and the eye or the obesity. So what is the link, that mechanism of the linkage?
There are many mechanisms.
Okay, so would you please give us one or two biggest hypotheses?
Well, this is all in my talk.
Right, that's a reason
But what's important is what is happening in the first years of life. The first years of life are when the tendencies begin. You can grow on this curve, or you could grow on this curve.
Right.
Your immunity can be on this curve or on that curve.
Right.
And we know that if we perturb the microbiome early, we change the development. We change immunological development.
Right.
We've shown this in many different ways. I'm just going to show one example, but we've shown that T cell populations change, for example. In reality, for a young animal, there are only 3 decisions that are important: how much energy to spend or to save.
Yes.
What is self and what is not self, and who is a friend and who is a foe.
I see.
Immunity, metabolism, immunity, cognition.
I see.
And the microbiome provides context for that through interactions with cells. We show that when we perturb the microbiome with antibiotic, now the cells in the intestine, their gene expression is different. It's different in certain stereotypic ways. Okay.
So it is said that the first 1,000 days after the born is very important, critical, because of the epigenetics. So your hypothesis is also the microbiome is controlling the epigenetics?
Yeah, absolutely. And in fact, I'm going to show a slide that shows that.
Wonderful.
First, it turns out that the microbiome develops its adult form in the first 3 years of life.
Wonderful.
And then after that, it is adult.
Okay. So this is the aging society, and how do you apply your strategy to the prevention of aging or the prevention of the age-related disorders?
Well, there are 3 different applications.
Right.
I'll start with the most obvious, but it's the last one I discuss, and that's cancer. Basically, cancer is aging in general.
Right.
Cancer rates go up log linearly with age.
Right.
And if cancer rates are high, that's aging.
Right.
So the microbiome is changing risk of cancer. Second are metabolic diseases like diabetes.
Right.
Microbiome is affecting diabetes rates.
Right.
Third, I forgot. What's the third? Oh, well, obesity. Obesity, like diabetes, obesity affects late in life events.
No cardiovascular?
It starts at obesity and it goes through cardiovascular.
I see. I understand.
Actually, there were some slides I took out because I don't have enough time. We did a study in the United States in Japanese Americans in Hawaii with Professor Abraham Nomura. We did a whole series of studies. But in one study, we looked at men who developed stomach cancer, and we compared them with men who did not. And because we had found that Helicobacter pylori was very important in stomach cancer, we limited the study only to people who had Helicobacter pylori. So the universe was H. pylori positive, and half had stomach cancer and half did not. And then we asked, how many brothers and sisters did you have? What was your birth order? And in both cases, we found significant relationships.
I see.
And that means that microbial transmission
Oh.
was different. So the events of the first 2 or 3 years of life affected their risk of developing cancer 70 or 80 years later.
I see. So it's epigenetic affects
In
the
that case,
aging.
we don't know the mechanism.
Oh.
We just know the observation.
Observation.
We don't know the mechanism.
I see. So you are in Mayo Clinic.
No, that's one of the other speakers.
Oh, you are in the which?
I was at New York University.
Oh, New York University.
But now I just transferred to Rutgers University.
Rutgers University.
Rutgers is the state university of New Jersey. It's like Ohio State or Michigan State in New Jersey.
So how are you doing some clinical application in your university?
Right now, I've just moved, and I'm setting up my translational research lab, but I'm hoping to build a university-wide microbiome program involving clinical trials.
So what is the possible intervention through the microbiome? Probiotics or prebiotics, or the combination of the bacteria? Or?
Yes. So I think probiotics is very important, but most of the probiotics today are not very good. The field is driven by marketing and sales, not by science.
Right.
Most of the probiotics that are available at the store have never been tested, and they haven't been tested for specific clinical indications.
Right.
I think there will be a very healthy probiotic industry in the future, where we will know what is the probiotic that we should give to you. What should we give to you for which condition?
Individualized
based on what their microbiome. It's one of my last slides. I think we're going to test babies, and we're going to see what the babies are missing.
I see.
And we're going to give them those organisms.
How about the prebiotics?
Prebiotics are part of the whole probiotic.
Oh, so your concept of probiotics include the prebiotics also?
Yes.
I see.
Yes.
Then finally, we have been talking about maybe intestinal microbiome, but how about the other parts of the microbiome?
Yeah, so that's a good question. Most of the emphasis has been on the intestinal, because it is such a big compartment.
Right.
It is really very major in human biology. The most important interface is in the intestine.
Right.
Where, I'll show that as a slide too, where it has connections to the liver and to the fat. It has connections to immunity.
Right.
It has connections to the brain. So that's the center. Probably all of them are important. And I think it's also important to say that studying the microbiome is a scientific frontier.
Right.
We're early in the frontier. It's very promising, but we're very early.
Recently, the microbiome has been pulling the attention. How do you think about the connection oral and the intestinal?
Needs to be studied.
And
by the way, another area which I don't discuss, but is a very interesting area, is the relationship between the microbiome and neurodegenerative diseases, like Parkinson's disease. There's more and more evidence that the microbiome is involved in Parkinson's disease.
Yeah. The Parkinson's... PCO.
Yes, we hear about the PC.
Yes, this is Apple.
Yes.
Let me just...
So this is the file you're using for your presentation?
Yes. I can do it on my computer.
Yes.
That would be best for me. Or we could put it on a USB key.
Either way is fine with us.
So let me give you two things. First,
Yes.
you can
HDMI and this is the use. Yes.
Okay. Second,
Power cable. Yes.
okay.
That's great.
And then I just give you my password for my screensaver. Do you have
Or maybe you can just
Okay.
sitting delete. So so you would like to use your own computer?
Yes, I think
to
it's,
present
yes.
this.
Yeah, because I just have to speak for 1 hour.
We have a PC review center downstairs, and could you register your PC there?
Yeah, we can finish in 5 minutes.
Ah,
So,
okay. All right.
if you can escort him.
Okay then.
So, and also he would like to eat.
Well,
Yes,
maybe
I'm
I
sure.
don't, maybe I
This
don't
is
eat
your
very
lunch.
much at this point. This is just for my,
Password for your PC. Thank you.
So let me finish.
Yes, okay,
Maybe
fine.
it's okay. So
should I give you this in the meantime?
Oh, I just later on then.
so he will escort you to
Okay,
downstairs
fine.
with you.
Okay, good.
Yes. So also we have finished the oral. Then the other
So I mentioned big interest in Parkinson's.
Parkinson. Yeah. So yeah, people are believing that microbiome is a key for the development of Parkinson's
Yeah.
disease.
So if it's a key for the development, then it's probably key for the prevention.
Prevention. I see.
Treatment, I don't know, but prevention. This looks very nice.
So it's an anti-aging obento. So, okay. As a clinician, that the difficulty is getting a stool from the patient. Do you think it's going to be some alternative way in the future to accelerate research in this area?
I think that once the public understands how important stool is,
Yeah.
it will be easier to get it.
Okay, so the concept
For-
might
for-
change.
Yeah, I think so, because you wouldn't do a clinical study now without getting blood tests.
Right.
So I think that the stool is more informative.
I see. So in the
But-
future, stool
Yeah,
is
and you know, in certain traditional people, they won't give you blood either.
right. I see.
But
I see.
now we have learned to give blood.
I
so
see.
we'll learn to give stool.
So
too.
blood and stool come together for
and,
the
and urine too.
urine.
Yeah,
too.
urine
Okay.
has a lot of metabolic information.
I see. Okay. So finally, what is there any other final words to the member of a society from your research, or the lifestyle advertise, or the advice or something, anything you would like to say finally?
Yeah, what I have to say is actually very complicated.
But please give it to him in a very simple way.
I had slides, but I removed them because I don't have enough time.
Right.
But we think about the bacteria that live in the human body as symbionts.
Yeah.
They live together with us. They help us. During our reproductive life, they help us reproduce.
Right.
So that we can live our life and then have a new generation so that we can provide a home for them. But after reproductive life, they often kill us through infections,
Right.
cancer, and many other things. So that is very bad for the individual,
Right.
but it is good for the species.
Oh, interesting. Very, very insightful.
Yeah. And we have done mathematical models that have shown this.
So marriage is good for the kids. So, okay, thank you very much. So I'd like to conclude.